Greetings, Scott here, known as Cantaloupe to some online, with another video, and I want to talk to you today. It is January 1st, 2025, New Year's Day. Happy New Year's. I want to talk to you today about kind of a funny subject to not be in front of a computer to discuss. That is shaders. If you know what shaders are, it's a graphics tool or system, pretty common in video games and other graphics applications nowadays, where it gives you access to the hardware on your computer or device that is dedicated to graphics. So it's optimized for speed and parallel computing. And I just want to give a real quick overview without any kind of technical data on the screen as to what the components are, because I'm kind of learning this system myself, and this might be of use to somebody who's just getting into it, struggling with a conceptualization of what it does. So anyway, short video, quick background about the main library that is used by pretty much all of these applications, called openGL. And there is a proprietary version made by Microsoft called DirectX. I don't know if that's still in common use, but it's kind of does similar stuff. But anyway, this is about openGL and its various flavors. So there's the web version, which is what I'm learning myself right now, and they all have commonalities. All the openGL libraries have similar features, and I'm going to cover just a couple of those real quick, because I finally gotten a grasp on what those are and what they do. So the pipeline, it's called a graphics pipeline, and it's a little bit complex for a reason. This is my thing that I've learned recently, that it's not so much badly designed, which I used to think. I really had a lot of resistance towards getting into GPU programming for graphics. I've traditionally been a CPU or software graphics guy my whole life, and I've dabbled here and there with shaders just enough to know that I didn't like them. The level of complexity, the convoluted programming that you have to get into, there's a bit of a learning curve, and it just seemed bad. It wasn't fun to program. So now that I've kind of forced myself to learn it, I'm not no expert yet, but I've gotten enough into it so that I know what it does and I know how it fits together. So I have a new appreciation of it. I like how it's set up, and I understand that it's set up that way for a reason, and it has to be for the purpose specifically of parallel computing. Now, shaders have two main components. They're going to have the vertex shader and the fragment shader, and I can describe pretty clearly and accurately what those are and their differences right now. So you will have usually some kind of framework on top of your shader to help manage the vertex and fragment shader components, and these are actual programs, like very similar to C. If you're familiar with C programming, they have a main function that is the entry point for the program, and there's a main function for each of these components, the vertex and the fragment, and they are run, well, the vertex, just in a nutshell, the vertex component, the program, is run per vertex, okay, like the name suggests. What is a vertex? It's a point. It's either two-dimensional or three-dimensional, whatever coordinate space you're working with. It's a point in that space, and your vertex shader is called, if you call it, optionally, per vertex for your model data or whatever you pass to it. And there's a lot behind that, and I'm not going to get too detailed, but your fragment shader, on the other hand, and this is a real good thing to know if you're getting into this. So the difference is your vertex shader is your points for, say, a polygon, usually triangles because they're efficient. The GPU is optimized for triangles, but you don't need to necessarily use triangles. You can use quads. Those are pretty much the only two things that you're ever going to see on GPU. But the fragment shader is the pixels. It is called per pixel. It's a program with the main function just as the vertex shader has, but the fragment shader has this program running for every pixel between your vertices for what's called a fragment or a polygon. It's kind of the same idea. So imagine there's a triangle on the screen. Your points of the triangle are your vertices, and your vertex shader is going to be called once per vertex, so 3 times for a triangle. And as many pixels as happen to be within that triangle on the screen are going to be called, or the fragment shader program will be called once per each pixel. Now, it sounds like a lot of programs running, because it is. It's amazingly parallel, and you're only writing 2 programs, and they get called a lot. And that's you have hardware on your computer. It's called a graphics processing unit, and it has memory, and it has architecture to support massively parallel code. That's what it does. And it's why it's fast, and it's why you can, achieve the amazing graphics that you see in video games. But a little bit more about the fragment shader. So the fragment shader will have potentially attributes like color. You can pass it a texture. It's a really big subject, and I'm not going to try to get into every little thing, but you have also there's a third very common component that goes with these two shaders. So you've got your vertex shader, your fragment shader, and you have what's called a uniform, or a set of uniforms, and those are it's information passed to the shader programs from your managing application, or your framework, or for example 3JS, or your game, whatever is invoking these shaders, whatever is involving the shaders in the application, will pass what's called a uniform, or a set of data to the shaders, so that they know something. I mean, a shader doesn't do anything unless you give it information. You have to pass things to it. So that's how you do that. Anyway, that's kind of the substance of this video. All I really wanted to go over. Reach out if you have questions, and I'm going to maybe make some more videos about this subject as I continue to learn myself. So hopefully that's helpful to people, and you can contact me at whitehotrobot@gmail.com. Happy New Year again, and have a good day. Thanks.